Now we are going to talk about each and every features like multi-core and parallelism, data locality in memory, and columnar structures. Okay, basically what is basically all these features? So that we are going to talk. Just take on PPT. Okay. Okay. So basically what the core things like, why HANA becomes so powerful? Because of these features. One is data locality in memory. Data locality in memory. And then second is columnar structure. Third one is multi-core parallel processing. Multi-core parallel processing. Okay, so basically these are the three features. Because of this, HANA becomes so powerful. It has other things also, as I said, like it's a platform and it has its own libraries, all those things. It has many things, but when it comes to the powerfulness of HANA, so because of only these three reasons only. Okay, what is basically data locality in memory? So basically how the system architecture. System architecture means like the general any computer architecture, how it will be. Like basically it will be one CPU will be there, CPU, and then it's going to be one RAM will be there and one hard disk will be there. So this is how a general architecture of any system. If you talk about any system, means like it can be individual your laptop, it can be your desktop or any server also, big servers also. The same architecture it follows, right? Basically, what happens like any instructions if you give, first it will reach to CPU, then from CPU to it goes to RAM, and then it goes to database. Hard disk, right? So this is how okay. So this is the basic system architecture. Suppose if you want data, any data from hard disk, what you do first? So just the signals will go to CPU. From CPU it goes to RAM, and from RAM to it goes to hard disk. Okay. So this is right. Both are the RAM, and the RAM is nothing but in memory. Okay, and hard disk. Both are having a capacity to store data, but RAM is kind of a volatile memory and hard disk is a permanent memory, right? So this disadvantages, okay, because of the RAM, volatile memory, and this memory is also very less memory. Okay, because of this we were not able to achieve the data extraction much faster. Okay, so extracting data from hard disk to CPU is very slow, because this this technology of hardware, what we were using is a kind of, iron plates. So data extraction from the iron plates will be very slow than the data extraction from CPU to RAM. Basically, the RAM, the hardware is it's a combination of the transistors and capacitors, and altogether it's a different hardware what we are using with the hard disk and the RAM. Okay, and the data accessing from RAM, it is much faster than the hard disk. Okay, but 1980s, whatever the databases what we are having, all are based on this architecture only. Okay, so always the data will be pulled from hard disk, okay, through RAM, and then it goes to display part. So that time we were facing too much slowness while extracting the data from the hard disk, which is consists of the iron plates. Okay, so now in the 90s, when it comes to 90s, so the RAM hardware, it becomes cheaper. Okay, the RAM hardware becomes cheaper, and with that advantage, okay, so this SAP people, they found that so this in-memory feature we can add into one database, so that it can become easy to get the data from the in-memory itself. That means that data locality. So here only we are going to keep the data, okay, in RAM itself, because now RAM is cheaper and the data also we can store it more data over there, so that no need to go to hard disk from CPU itself. From CPU to RAM, data will be extracted, and it is much faster than the hard disk. So this is what the data locality in memory feature. Okay, only because of the RAM hardware become cheaper when it compares to 1980s and the 90s. Okay, so that is where we are in now 2019. Okay, but we started this HANA started in 1996. From 1996 onwards, okay, this HANA database, the research is happening. Research from 1996. Okay, so for this the main reason is SAP is working from 1996 in around 2006 and Vishal Shekhar came. Okay, so Vishal Shekhar, he is the I think you guys know that Vishal Shekhar. He, recently also he was with Infosys CEO. Okay, and he is the guy you can say father of HANA. Okay, he is the one introduced the HANA to public. Okay, so he came in 2016. So in between that, lot of research happened from 1996 onwards. Okay, so with they were having P-time, one of the databases, and a lot of other things. Okay, so lot of other people also involved, but he's the guy he came from his journey completely this database completely it's evolved drastically. Okay, and with that it became all these features. So data locality in memory and columnar structures and multi-core parallelism. So this is what the data locality. So data locality in memory means in RAM the data will be available. So from RAM easily you can get the data. It is faster for a retrieval purpose. Okay, and now we are going to talk about what is columnar structures. The columnar structures is one of the new features. It's not a new feature to the market. There was already one database. That database also is a database only. SAP database only. So what is that database? It was a Sybase. Sybase is the database which was having columnar database. Okay. Before HANA also, the Sybase was using columnar database, and it is more successful database. And the later point of time, like when SAP also acquired that Sybase, it became a SAP property. With that, they could able to easily, take the technology and incorporate it to HANA. So what is basically, columnar structures? Columnar structures are nothing but this is the, if any data stored in the database, generally this all, till now what we are using like Oracle or DB2 or MS SQL, all these things, these are all row structures. With the row structures, what is a disadvantage? Like when you are accessing data from the row structures, it is slower, because whether it is required or not, suppose if there is a table has a 10 columns, if you are accessing 2 columns data from the table, so internally how the search will happen, for the 10 columns, the control will go and extract that for 2 columns only. Okay, that is a disadvantage with the row structures. But when it comes to columnar structures, whichever the columns are required, the only specific, in our example, only 2 columns as I said, right? Only 2 columns only it goes and it fetches the data. Okay, so that is where the major difference happens, and that is where the columnar structures are faster for the data retrieval, and the row structures are faster for the data updation part. Okay, for retrieval, columnar structures will be useful. For the data updation part, okay, for writing part, if you are writing data into the database, anything, suppose any transaction, if you are saving, suppose any sales order is being saved, so for that it is going to be row structures. If it is a row structures, it is good when you can achieve faster performance. But for data retrieval part, if it is a columnar structure, it is good. Okay, so this technology SAP took from Sybase. Okay, from Sybase, now it is incorporated in HANA. Okay, so that is the columnar structure. And next is, we are going to discuss about the multi-core parallelism. So multi-core parallelism is nothing but, suppose let's assume there is a CPU. Okay, so this is a CPU, right? Okay, so multi-core CPU is nothing but inside CPU it will be having again mini CPUs. Okay, like this. Okay, so like this it is 4-core CPU. We are hearing, right? It's dual core, quad core, all those things. So the same HANA is also using multi-core CPU system. Okay, so what is basically the advantage when you have a multi-core CPU is nothing but, simple example I will give you. If you want to paint a room, okay, if you have one painter, so he will paint, one by one wall, at a time, right? So if you have four painters, if you want to paint a room, so every painter can be occupied one wall, and simultaneously the work will be done and it will be faster. The same concept here also, multi-core CPU is also nothing but one activity will be distributed to multi-cores, and the cores will be activating, so parallelly, and it will be perform the same activity at the same time, and it will be giving results very faster. Okay, so that is the multi-core feature. With this multi-core feature, the HANA becomes so powerful to execute the transactions. Okay, so this is about the three main features. One is data locality in memory, and this is columnar structures. This is multi-core CPUs with a parallelism. Okay. So this is what, okay. So once this are all they found, okay. So when Vishal Sikka was joined, he also was asked to work on databases. Okay. So with that remembrance, Vishal Sikka, okay, let's have Haso's name only on the product. So that's the reason he put it Haso's new architecture. Okay, it's a completely new architecture based on HANA. The complete everything, the applications paradigm has been changed. How SAP was used to be, that's completely rewritten. That is what now it is going. Now it is S4 we call it simplified for HANA. S4 application from ECC, whatever the programs which were written based on the previous databases like on Oracle, MS SQL, based on that programs all have been written. After HANA, it is completely rewritten, completely the database, extraction logics and processing logic, everything was rewritten. Okay. So new architecture, everything is going to be now. Okay. So these are the features I told you, right?